Hi everyone, in this video we're going to look at a few examples on simple harmonic motion. Now just to recap on what we learned from the intro, we've got simple harmonic motion, which is the acceleration of an object moving in rectilinear motion is proportional to the distance away from the center point of the motion. That's that basic equation that we've got written here. Okay, we did worked out that a solution to that equation could be this: a sine kt plus alpha. Now if the timing, or if t equals 0 is at the center point where we start, we'd use sine. If the timing, or when t equals 0 occurs when the object is farthest away from the motion, then we'd probably use a cos graph, just because a cos graph starts out there like that, so it makes more sense to use that one. Now this is also a solution to that differential equation, a cos kt. Now if we know some more information, like that the object started at when t equals 0 it was at x equals -1 or something, that will help us to find what this is here. Okay, so I'm going to show you an example of doing that. We know the period is 2 pi over k. We know the amplitude is a, and that's how far from the middle of the motion to the top of the motion, and we've got a few equations here for the velocity. So this equation here just comes from doing the derivative of this function here, and also we showed how, as part of deriving the formula, we know how the velocity is also equal to that. Remember, x all the time here is the distance from the center point. So the velocity, the maximum velocity, is k times a. The absolute value there is because we might get a negative. So if we're talking about speed, then the maximum speed is modulus of ka. First example, here we've got the second derivative is equal to -16x. Now we've used a bit of shorthand notation here. Really what we should have is this. That's the second derivative, -16x. Now you can just compare this directly to the formula that says the second derivative is -k squared times x. So if we were trying to find the value of k, which here we are, we can quickly see that k is equal to 4. Now we could say plus or minus 4 here, but -4 is not going to make any sense in this one here. So we're just getting the value of k as equal to 4. So the period of the motion is 2 pi over k. So the period of the motion here is pi over 2, and normally we'd be talking about seconds here, so pi over 2 seconds would be the period of the motion. Now we could actually work out what the equation of this would be. So we know that one of the solutions to this equation is going to be a sine kt. So assuming that this motion starts at the origin, we could say that x is going to be the amplitude here. So we don't know, this question is not telling us anything about the amplitude, so I'll assume it's 1. So it's going to be something like sine of 4t, sine of kt. So that's going to be the equation of the motion. If you do the derivative and then do the derivative again, you'll see you get -16 times the original function. Okay, example 2. Prove that the motion is simple harmonic in this case. So we need to prove for A that the second derivative is equal to -k squared, or a constant, times the initial value here. So we've just got to do the derivative, and I'll use the shortcut. The derivative of 4 sine 2t is 4 cos 2t times 2. So that's 8 cos 2t. Second derivative, so to do the derivative again, the derivative of 8 cos 2t will be -8 sine 2t times 2. So -16 sine of 2t. Now I want to write that as -k squared times our original function. So I can see our original function is 4 sine 2t. So if I put a -4 at the front there, I've shown it. Okay, so the second derivative is -4 times x. So that's definitely, we've got simple harmonic motion here. And in this case here, we can also say that k squared is equal to 4, and we can say that k is equal to 2. That's going to help us to find the answers to B. So the period is 2 pi over k, which is pi. So the period here is pi. It's repeating every pi. The amplitude here is 4. So you can see, go back to the original function here, you can see that it's 4 sine 2t. So we're going up and down 4. It's repeating twice in 2 pi. How far does the body move in the first second? Alright. Easiest way on your CAS. We're looking at the integral between 1 and 0 of the velocity. Remember, the integral, or the area under the velocity curve, velocity time curve, will give us displacement. So here, the velocity is 8 cos 2t. Okay, and do that on your calculator, and you should get the correct answer, which is 4.36 meters. And just check that that's correct. Here's another way of thinking of that. Here I've got a graph of 4 sine 2t. You can see it's going between 4 and minus 4. It's repeating once every pi instead of 2 pi. We want to know how far have we gone between 0 and 1 second. Okay, well you can see from the graph that we've stopped at 4 and we've gone back the other direction. So the velocity was 0 there at pi over 4 right here. So I mean, if we said how far have we travelled in the first pi over 2 seconds, we've gone up to 4, then we've gone back to 0 again, so we've travelled 8 meters. If we said where are we at 1 second, we can easily answer that by substituting x is equal to 4 sine 2 times t. So we can get that on a calculator. Remember, this is in radians, so 4 sine 2, calculator in radians will say we're at 3.64 meters. Of course, that's not the answer to the question, because I can see from the graph that we've gone up to 4 meters and come back the other way. We're going back towards the other way. So we've covered 4 meters, and really what I know is what's the distance between there and there. How far have we come back? So clearly, if we're at 4 meters at pi over 4 at 0.785 seconds, at 1 second we're at 3.64 meters. We've travelled 0.36 meters in that time, giving a total of 4.36 meters for the distance we've travelled. Again, doing it on your CAS, a lot easier, but it's also good to understand. Okay, example 3, we've got a body moving with simple harmonic motion about some mean position O. The amplitude is 0.5, the period is 2 pi, and when t equals 0, the body is at O. Find the two possible expressions of the form A sine kt for the displacement of the body. So we just want a formula for x in it here. I've drawn this little graph here to give the two possible answers that I'm going to get here. So the period is, remember, 2 pi over k. We're looking for, it's even given us the form of the answer, which is nice. So it tells us the period is 2 pi. So 2 pi equals 2 pi over k. So we've got k is equal to 1. That's nice and easy. So we know k is equal to 1, and we know the amplitude is 0.5. So really easy. It is 0.5 sine of t. Now we're not told if we're going up and away or going backwards. That's why we could have plus or minus here. So there's the two possible answers here. 0.5 sine t, which you can see in the blue graph, or negative 0.5 sine t, which is the green graph there. Okay, in both cases the amplitude's 0.5, the period is 2 pi. So either one of those will work. For part B, find the speed of the body when t is equal to pi over 3. Okay, so the speed is equal to, so we're just doing the derivative of this function here. So that's going to be plus or minus 0.5 cos t. Okay, so then we're going to substitute, in this case, pi over 3. Cos of pi over 3 we know is a half. So we've got plus or minus 0.5 times 0.5. So plus or minus 0.25. So it really depends on which equation it is as to what the speed is, the velocity is I should say. And I've shown that on the graph here. In one case the speed's positive, and the other case the speed is negative. Sorry, I should be saying velocity. So the question says what's the speed? And remember, speed is just the modulus of the velocity. Okay, so I'm asking for the speed here, so there is only one answer, 0.25 meters per second. Last example on this video, we've got a body moving in simple harmonic motion about some mean position O. This is a bit spicier here. The amplitude is 2 meters, easy. Period is pi over 5 seconds, easy. We're going to be able to find k. An extra bit of information here, when t equals 0, the displacement of the body is 1 meter and the velocity is positive. Okay, this one's a bit more intense. Find an expression for the displacement of the body from O at time t, giving your answer in that form there. So we're going to want it in terms of k, our sine, and we're going to have this phase shift going on, which is that information about x being 1 when t equals 0 is going to help us to find that. Okay, let's do it. So the period is 2 pi over k. So the period here is pi over 5. So if we times both sides by k and divide by pi over 5, we get k is equal to 10. Or you can just compare those directly. 2 pi over 10 is the same as pi over 5. So therefore k is equal to 10. We're told the amplitude is 2 meters, so I think that we're in a position now to write this is 2 sine 10t plus alpha. Alright. Now, the extra bit of information to find alpha, we know that when x is equal to 1, or when t is equal to 0, x is equal to 1. So let's put that in. 1 is equal to 2 sine 10t plus alpha. No, t is equal to 0. So therefore 10 times 0 is going to be 0. So this just gives us that equation there. Okay, so we get sine of alpha is equal to a half. So pi over 6, or possibly we could have 5 pi over 6 for angles between 0 and 360 degrees. So we've got pi over 6 here, and also 5 pi over 6, so 30 or 150 degrees here. Let's leave our answer as radians. The question does say alpha has between 0 and pi, so we have got these two possibilities. So which one is it? Well, the question also has this extra little bit of information that the velocity is positive. So I've got two possibilities here. We've got x equals 2 sine 10t plus pi over 6, or we've got the possibility that we could have 2 sine 10t plus 5 pi over 6. Okay. So now let's look at the expressions for the speed that we'll get for these two possible answers, 1 and 2. So in the first case, we've got that the speed will be 2 cos 10t plus pi over 6 times by 10. Okay, so I'll just simplify that, make it nice. It'll be a 20 at the front there. In the second case, the speed will look very similar, but it'll be 20 cos 10t plus 5 pi over 6. Okay. The small bit of information here tells us that when t is equal to 0, the velocity is positive. So if we look at these and we substitute in t equals 0 in here and here, we'll find that in the first case the velocity is indeed positive. 20 cos pi over 6 is positive. In the second case, 20 times cos of 5 pi over 6 is negative. So that tiny bit of information helps us to know that we're really dealing with case 1, and this is the correct equation for the displacement. Part B asks what is the greatest speed. So not the velocity, we're talking about speed. Alright, so if we look at these equations here and look at this equation for the the speed here, you can see that the amplitude of this function here is 20. It's going between 20 and minus 20. So the greatest speed you're going to get is 20 meters per second. And the greatest acceleration that we're going at. Alright, so let's look at the acceleration. The acceleration is just the derivative of the speed. So I'm going to take 20 cos 10t plus pi over 6, do the derivative. That gives me 20, or negative 20 sine 10t plus pi over 6 times 10. So negative 200 sine 10t plus pi over 6. Alright, so I can see that the acceleration is the biggest it could possibly be is 200, the least it could possibly be is negative 200. So the maximum acceleration is equal to negative 200 meters per second squared.